Are we starting or? Yeah. Hi everyone, my name is Katya and I'm the CFO of ZeroAvia. And today I'll be going through some of the most commonly asked questions by investors.
Yeah, so repeat the questions. So the first one, isn't hydrogen just for small aircraft?
Absolutely not. So we're starting with the small, isn't hydrogen just for smaller aircraft? The answer is absolutely not. We are starting with small aircraft, as you will have seen through the testing that we've done so far, and that's because the technology there is ready, and we are a practical company and we believe that we have to start small and work our way up. But the technology can and will scale. So today we've already scaled it from 6-seater to 20-seater. We're working now on scaling that from 20-seater to the 50 to 100-seat regional category. And actually just in May we announced a partnership with Alaska Airlines to do that. But over time we're going to be scaling it to narrow-body aircraft and beyond. There are a number of changes that will need to happen to the technology to enable that. For example, we'll have to move from low temperature, most likely to high temperature fuel cells. We'll also have to move from gaseous hydrogen to liquid. But those are all things that we're working on now. And the improvements that we'll need to see in the tech are in the order of 2 to 3 times rather than 10 times plus. So we think absolutely the tech will scale and we'll get there over time.
The next question, is the infrastructure a big challenge? How will we build out the infrastructure to provide hydrogen to the aircraft?
Yeah, so is the infrastructure a big challenge? The short answer is yes, it is. But for that reason, we as a company are not just selling engines and letting customers get on with it. We are selling a new fuel type as well as a new engine. And so we are working on that directly ourselves to bring that to market in order to meet our commercialization timelines. We think hydrogen is actually very well applied to the aviation industry. So aviation is a great anchor for the demand for hydrogen and will actually help the hydrogen economy take off. Because it's concentrated high volumes at known locations. So there's something like 60 airports in the UK as opposed to thousands of charging stations that you would need, for example, for automotive. And so that challenge, while it's not easy, it's a simpler optimization problem than it is for some other sectors. What we are doing at ZeroAvia, I think, is working on a both bottom-up as well as top-down. So bottom-up, we have our own electrolysis at our experimental locations, as well as our own refueling infrastructure, logistics, ground handling, all of that, because we want to be able to show to customers and to investors how this works at small scale and that we have real practical experience handling all of that. But at the same time, we're working top-down with big partners who are going to help us really scale that to commercial applicability. So for example, Shell is one of our investors. We're working with them. We have partnerships with airports, we have partnerships with electrolyzer companies because we want to make sure that the volumes will also be there once we're rolling out at scale.
What about the cost of all that? Is it going to be massively expensive to move to hydrogen? To switch over to hydrogen aviation, will that cost exponential amounts of money?
Yeah, so the cost, of course, the question always comes up. First of all, is the hydrogen itself going to be more expensive than jet? The short answer is no, it won't. So the break-even cost of hydrogen for our operations is something like $6 a kilo, and there are targets already that are way beyond that. And so we think in the very, very near term, at a small scale, it will cost a bit more than jet, but we're going to come to cost parity and cost advantage very quickly. In terms of the capex cost of the transition, yes, it will cost money, but I think it's a bit misguided to look at the absolute cost, and really we should be thinking in terms of incremental cost over and above the infrastructure spend that will anyway need to be put in place to meet the rising demand. There is some incremental cost, but these are numbers that are relatively small in the grand scheme of things. So they're in the order of a few small percentages of the GDP of a small country, and the economics, the return potential is there. So this money is going to flow because the offtake is going to be there from airlines. So the investment will be made. Yeah.
How much renewable energy is going to be required to be able to fly hydrogen? To use green hydrogen?
Yeah, so the renewable energy requirement, it's another common question. People say, like, there's going to need so much renewable energy, shouldn't we just use that renewable energy for something else rather than making hydrogen only to put it back into electricity? So yes, it's going to require a lot of energy, something in the order of 3,800 terawatt hours. But that's equivalent to something like 30% of the North Sea being covered in wind turbines, which is something that is a large number, but we think we'll get there. And we think, again, hydrogen is going to be a really important anchor for the growth of the renewable energy generation capacity globally. And there's many huge projects happening around the world, in Australia, Morocco, places like that, that are taking renewable production to a whole new scale. And again, we think the hydrogen is going to be anchoring that demand and accelerating that transition. And also it's worth noting that we have time to get there. So all of this energy is not going to be required tomorrow. This is the number that is needed to transition the whole industry to hydrogen over the next few decades. We're not going to be there tomorrow, unfortunately. It's going to take us some time to scale up from the small aircraft to the large ones. And so we have time also to make the business case and get all of that coordinated to roll that infrastructure out.
Safety is a big question. Is hydrogen going to be safer? Will it be more dangerous to fly hydrogen?
That's a very common question, is hydrogen safe? The answer is it's actually more safe than jet fuel for a few reasons. So one is hydrogen is the lightest molecule, so it dissipates very quickly. So for example, if there was any kind of leak, it's very difficult to keep hydrogen in a form that is ignitable because the molecule is very light, so it dissipates almost instantly. Second reason is that our system is electric. There's no combustion, there's no heat in the system itself. So there's really no source of flame on board of our aircraft. But even if there were to be some sort of leak and there were to be a source of flame, again, keeping it combustible and ignitable is very, very difficult. So the systems that we have, it would be almost impossible to imagine a fire actually spreading across the system. But another thing worth noting is the tanks that we're using, hydrogen tanks, they've actually undergone a lot more testing than conventional jet fuel tanks have today because they've been developed for automotive. They've gone through all sorts of quite intense sort of crash tests and things like that, and so the possibility of any kind of rupture and leak is very, very low to begin with.
What drew you to want to work in zero emission aviation, to work at ZeroAvia?
What, sorry?
What drew you to want to work?
What drew me? So people who often ask me about sort of my career in aviation. So my career in aviation is quite short-lived. I've been in the industry for about 4 years, but I started working here really because of the climate challenge. So I think probably about 10 years ago, I decided to pivot my career in finance towards working on climate change, and I looked at my own footprint and I realized that I can stop eating meat, I can recycle my clothes and do all sorts of stuff like that, but really as long as I keep flying, my footprint is going to be very significant. So I have a choice: I either stop flying or find a way of flying in a way that doesn't cost the planet. And so that's for me the reason I decided to work on this challenge, because I think it's a huge problem. It's a hard to abate sector. There are no real viable solutions at the consumer level, but more importantly at the kind of industrial level. And I think more people need to put their minds together to figure this out. And I think we need talent from this industry, but also cross industry, to bring parallels from what's worked in others, but also learn from what hasn't, and really help to figure this challenge out together.
How would you characterize investor confidence or investor excitement in aviation? You're seeing a lot of interest from investors.
Yes, I mean, investor interest, I would say overall, since I started working in the company, it's gone up every year, but for a few different reasons. So there's kind of the broader ESG interest, there's hydrogen interest, and there's interest actually specifically in what we are doing. I think the first two can be characterized as a bit faddish. I think those things hopefully are here to stay, but there's a lot of hype around those two themes for various reasons, and I think there's oversupply of capital in the system that led to that happening in part. But I think for us specifically, as we've continued to demonstrate progress, investor interest has deepened and has become more serious. So we really look at depth and quality of interest and not just breadth, and I think on that dimension we've seen significant improvement and continuation over the years. Because what we're doing is difficult. Our time horizons are long, and we're at the intersection of a number of quite complex and quite slow-moving industries. But 5 years ago, nobody thought we could get even a 6-seat prototype flying. Today we have a 6-seat and a 20-seater flying, and so we're going to continue breaking those stereotypes, breaking those expectations, beating timelines, and over time that will help to grow confidence more and more.
How is ZeroAvia different from competitors?
I would say we have a number of differentiators. The key one I would say is having all of the really critical technology in-house. And worth noting that we didn't start off with that. We actually started off as a system integrator, and we just went and bought everything that was available off the shelf to test what's missing and figure out what the best ways of bridging that. And over the last 4 or 5 years, we've decided to bring the majority of our core tech development in-house, because there's really nothing that's aviation grade that's available on the market. That's a very important differentiator. There's nobody else that has the same approach. There are a lot of people who are trying to use other partner tech, but nobody really owns and therefore controls the timelines of the key technology that's really going to help this take off. The other thing I would highlight is the partners that we have. So we're a propulsion company, but we have partnerships with all the critical customers and airframe OEM partners like Textron, De Havilland, etc., which nobody else has, and that's going to be a critical enabler to help us hit our entry into service timelines. And go through certification for this product and beyond. Thanks very much for tuning in, and if you have any other questions, feel free to reach out.